Pop quiz. Which salt will make pure water acidic? Potassium nitrate, methylammonium chloride, sodium fluoride, or sodium cyanide? Lock in your answer. We'll reveal it in a moment. In this video, you'll learn how some salts make water acidic or basic, how to predict the direction using conjugate pairs, and how to do a quick pH calculation for a salt solution. Here's the big idea. When a salt dissolves, its ions can act as acids or bases. An ion that is the conjugate of a strong counterpart is usually neutral. Conjugates of weak acids tend to be basic. Conjugates of weak bases tend to be acidic. Now, let us get to know more salts and their acid-base properties. Some salts are neutral. Potassium nitrate splits into potassium and nitrate, both spectators from a strong base and a strong acid. They barely interact with water, so the pH stays about 7. Other salts are basic. Fluoride is the conjugate base of hydrofluoric acid, a weak acid. It takes a tiny sip of protons from water, forming hydroxide, so the solution becomes slightly basic. Conversely, a cation that is the conjugate acid of a weak base, like methylammonium, can donate a proton to water and make hydronium, nudging the pH below 7. So how can we compare all these acidic and basic ions at once? Worry not, as a useful relationship ties it all together. Ka times Kb equals Kw. If you know the dissociation constant for a weak acid, you can get the basicity of its conjugate base, and vice versa. With all that we learned, it's now time to reveal the pop quiz. The acidic salt is methylammonium chloride. Methylammonium is the conjugate acid of a weak base, so it donates protons a little, shifting water toward hydronium and lowering the pH. Quick checkpoint. To figure out a salt's acid-base behavior, start by identifying each ion. Is it acidic, basic, or neutral? Then check what it's the conjugate of, and finally, compare its strength to water's autoionization. Want to lock this in? Your personalized practice test and flashcard set are all waiting for you. Tap the link and give yourself a quick check. Now, what if both ions matter? Take ammonium fluoride. Ammonium is a weak acid. Fluoride is a weak base. We compare their acid and base strengths. Because ammonium is the stronger of the two here, the solution ends up slightly acidic overall. If the acidic and basic strengths are very similar, like ammonium with acetate, their effects largely cancel, and the pH can be close to neutral. Let's calculate a pH. For 0.2 molar methylammonium chloride, we first find the acid constant of methylammonium from the base constant of methylamine using Ka times Kb equals Kw. Now, let's organize what happens in the solution using an ice table. We start with 0.20 molar methylammonium ions and none of the products yet. As the reaction begins, a small amount, let's call it X, of methylammonium donates protons to water, forming the base methylamine and hydronium ions. At equilibrium, the concentrations become 0.20 minus X for methylammonium and X each for methylamine and hydronium ions. Substituting these into the Ka expression, we could solve the quadratic. But because this acid is weak and X is very small compared to 0.20, we can simplify it by using the square root shortcut. Hydronium concentration is approximately the square root of Ka times the starting concentration. That gives a hydronium concentration of about 2.1 times 10 to the minus 6 and a pH near 5.67. Slightly acidic, just as we predicted for this salt. A few common pitfalls. Not all salts are neutral. Conjugates of strong acids or strong bases are usually neutral, and water's own ions matter only in ultra-dilute limits, not in typical classroom concentrations. Try a quick exercise. Potassium carbonate is basic because carbonate is the conjugate base of a weak acid. Ammonium nitrate is acidic because ammonium is the conjugate acid of a weak base, while nitrate is neutral. Sodium dihydrogen phosphate can act both ways, but in water, it tends to make the solution acidic. So far, we have identified neutral ions, spotted basic anions, and acidic cations, handled both active salts, and worked one pH calculation. You are ready for a final recap. Recap. Predict pH by looking at each ion's conjugate partner. Conjugates of strong acids or bases are usually neutral. If one ion is the stronger acid or base, it sets the pH. Use an initial change equilibrium table, nKa times Kb equals Kw, to compute pH when needed. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.